welcome back to my YouTube channel. In this video, I'll be discussing about how to use the sum and difference identities to solve for trig ratios. However, before you watch any further, don't forget to hit the subscribe button so you won't miss any of my videos. And if you do enjoy this video, don't forget to hit the like button and share this link to your friends. In my previous videos, I've shown you about the sum and difference identities. And as I told you in that video, the sum and difference identities is basically the elaboration of the trig ratios that does not use the special triangles, the special angles, so that you can solve it without using any calculator. So, there are 6 types of different sum and difference identities. They are the sine of A plus B, sine of A minus B, and then same thing for cosine, both of them, and then tangent, A plus B and A minus B. So, the reason why studying the sum and difference identities is important is that with the sum and difference identities, you can solve for trig ratios without using calculator, like 75, 105, 15. We all know that those are not the special angles, so solving it without a calculator will be really hard. However, with using the sum and difference identities, we can solve them. So then, in my previous videos, I've shown you 6 of the equations. So, let's use their knowledge to solve for these 6 questions too, of them regarding to the sum and difference identities. So, let's start for sine of 75. Well, before you start any sum and difference identities questions, you will have to figure out which sum and difference identities we are using. Are we using sine of A plus B, A minus B, cosine or tangent? Well, because we're trying to solve for sine of 75, sine, then we must be using either sine of A plus B or A minus B. So then, which of them? Well, first, let's assume. So then, let's assume that it's sine of A plus B. Well then, if you assume that it's A plus B, let's try to find the combinations, the A and B, because for the sine of A plus B. So then, after some trials and errors, we can figure out that it's going to be 30, we're going to be sine of 30 and 45. So 30 plus 45, that's going to be one of the combinations. Well, you can use other trig ratios like 45, 90, but in this case, let me just use the most simple one, 30 and 45. So that's the combination that we can find if we assume that it's A plus B. However, what if we assume that it's sine of A minus B? Well then, if it's A minus B, we can rewrite the equation that A minus B is equal to 75. Why? Because as I said before, we're dealing with sine of 75, and if you assume that it's A minus B, so it's going to be sine of A minus B. Because sine of A minus B is equal to sine of 75, then A minus B is equal to 75. So then, with this equation, we can know that A is going to be larger than 75. Why? Because if A is smaller than 75, let's say if A is 50, then for the B, it must be positive 25. Because if it's positive 25, you will gain 75. However, that is not the case because we're trying to find out sine of A minus B, not plus. However, what if you're asking that, what if we put minus but then we add negative 25? That will be equal to 75 and we will be using the A minus B. However, because minus combined with minus will be positive, so this will be the same thing as 50 plus 25. So then it must be larger than 75. And what special angles are larger than 75? Well, then it must be 90 and as some might say 180. So if A is 90, then B must be, if A is 90, then B must be minus 25. Because so, if so, you will get sine of 75. However, we know that 25 isn't a trig ratio. It isn't any special angles. And if we're using 180, it will still be the same. We're going to pair it up with 115. And we know that this is not special angles. So it must be sine of A plus B, because that's the only way we can figure out the combinations. So then let me just erase this part. So then, using the trig ratios, using the sum and difference identities for the trig ratios, we can figure out that this is equal to sine of 30 times by cosine of 45 plus by cosine of 30 times by sine of 45. And if you're asking why does this equation is used, don't forget to check my previous videos, because in there you'll be reviewed about the equations of sum and difference identities. So then, what is sine of 30? Well, sine of 30 is half times by cosine of 45, which is basically square root of 2 over 2, put in our plus, and then cosine of 30. Cosine of 30 is square root of 3 over 2. And then sine of 45 is square root of 2 over 2. And then, what's half times square root of 2 over 2? The square root of 2 over 4 plus by this one. What is it equal to? Well, square root of 3 times square root of 2 is square root of 6. And the denominator will be 2 times 2, which is 4. And then, because these two fractions have the same denominator, so we can just add the numerator. That would be square root of 2 plus square root of 6 divided by 4. And there you go. That's sine of 75. So isn't it exciting? Because with our sum and difference identities, we can figure out the exact values, not just an approximation of decimals for different kinds of trig ratios. So then, let's go to sine of 15. Well, because this is A plus B, then sine of 15 must be A minus B. So sine of 15 must be sine of A minus B. So then, what pairs can we use? Well, there are two types of pairs. You can use 45 minus 30 or 60 minus 45. But in here, I'm just going to use 45 minus 30. So sine of 15 is equal to sine of 45 minus 30. So then, using our sum and difference identities, we can figure out that this is equal to sine of 45 times by cosine of 30 minus by cosine of 45 times by sine of 30. So then, sine of 45 is square root of 2 over 2. Cosine of 30 is basically square root of 3 over 2 minus by cosine of 45, which is basically square root of 2 over 2 times by sine of 30. That's half. That would be square root of 6 over 4 minus square root of 2 over 4. And once again, we can combine these fractions so that we can get square root of 6 minus square root of 2 divided by 4. And the reason that this really looks like our answer for sine of 15 is because we're using the exact same value, 30 and 45 and 30 and 45. So, if you're asking, how can we find out the square root of 2 over 2, square root of 3 over 2, and so on? Well, that's the spatial angles, and there are two ways that you can know it. First is by memorizing it, or the second way is by using the special triangles, the 30, 60, 90 triangles, and 45, 45, 90 triangles. Also, if you want to know more about those special triangles, don't forget to check my other videos, because in there, I'll be telling you about the special triangles. So in the future, you won't need to memorize any special angles anymore. So then, if we figure out our sine of 15, so we can go for a sine of 105. So once again, we have to figure out which sum and difference identities it is. Well, to simplify things up, it's going to be the cosine of A plus B. And these A and B are cosine of 60 and 45, because 45 plus 60 is 105. And then we can put in our sum and difference identities, going to be cosine of 45 times by cosine of 60 minus sine of 45 times by sine of 60. Then cosine of 45 is square root of 2 over 2. Cosine of 60 is half minus sine of 45, which is square root of 2 over 2 also, times by sine of 60, which is basically square root of 3 over 2. And then for this one, there's going to be square root of 2 over 4 minus by square root of 6 over 4, which is this one. That would be square root of 2 minus square root of 6 divided by 4. And then for cosine of 15, once again we have to figure out the sum and difference identities we're using. And after some thoughts and logics, we can figure out that it's going to be cosine of A minus B. And then, what is the pairs that we can use for it? Well then, you can find out that that's going to be 60 and 45. Although you can easily use 30 and 45, as I said before, but this time, just for some variation, we'll use 60 and 45. So that would be cosine of 60 times by cosine of 45 plus, because cosine of A minus B uses plus, sine of 60 times by sine of 45. And then, what's cosine of 60? That's going to be half times by square root of 2 over 2, which is basically cosine of 45. You add our plus, and then sine of 60 times sine of 45. That's square root of 3 over 2 times by square root of 2 over 2. And then this is going to be square root of 2 over 4 plus by square root of 6 over 4, which is square root of 2 plus square root of 6 over 4. And you might think that this is exactly our sine of 75, square root of 2 plus square root of 6 over 4. Well, the reason is that we know that sine of theta is equal to cosine of 90 minus theta. And then, if we're using 75, so it's going to be sine of 75 is going to be cosine of 90 minus 75, which is cosine of 15. And then that's our cosine of 15. So then, let's go to tangent of 75. Well, what are the pairs we're using? We can use 30 plus 45 using our tangent of A plus B. So then, tangent of 75 is going to be tangent of A, which is tangent of our first value, our 30, plus by tangent of 45, divide by 1 minus tangent of 30 times by tangent of 45. And then, this will be, well, tangent of 30 is going to be square root of 3 over 3 plus by tangent of 45, that's 1. So you can write this as square root of 3 plus 3 over 3. And then, we divide it by 1 minus tangent of 30 times tangent of 45. Tangent of 30 is square root of 3 over 3 times by tangent of 45, which is times by 1. So you can write this basically this one. It's going to be equal to square root of 3 plus 3 over 3. And then we can use divide by, so what's 1 minus square root of 3 over 3? It's going to be 3 minus square root of 3 divided by 3. And then, because we know that dividing by a fraction is equal to multiplying it by its reciprocal, going to be square root of 3 plus 3 divided by 3 times by its reciprocal, 3 over 3 minus square root of 3. The 3 cancel out, so it's going to be square root of 3 plus 3 divided by 3 minus square root of 3. So there you go. And then, for tangent of 15, let's do it in bottom here. So then, tangent of 15 is going to be, we can put it into a tangent of a minus b. So then what will be the case? It's going to be, we can use either 45 and 30 or 60 and 45. This time let's just use 45 and 30. So it's going to be tangent of 30 minus tangent of 45 divided by 1 plus tangent of 30 times by tangent of 45. And then, what's tangent of 30 minus tangent of 45? Well, tangent of 30 is square root of 3 over 3 minus by 1. And then we divide it by 1 plus by tangent of 30 times tangent of 45, which is basically square root of 3 over 3. And then, what's square root of 3 minus 1? That is square root of 3 minus 3 over 3. And then divide is 3 plus by square root of 3 over 3. We divide it. And then, if we're dividing by a fraction, it's the same thing as multiplying by its reciprocal. So it's going to be basically square root of 3 over 3 divided by 3. And then we can put in times by its reciprocal, which is 3 over square root of 3 plus 3. The 3 cancel out, so it's going to be square root of 3 minus 3 divided by square root of 3 plus by 3. So there you go. That's our tangent of 15, square root of 3 minus 3 over square root of 3 over 3. So if you like this video, don't forget to hit the like button and share this link to your friends. And don't forget to check my other videos and hit the subscribe button. Thank you for watching.